Hello everyone, now we're going to solve some of the hard paper 2 questions from Cambridge IGCSE physics exams. A submarine is 20 meters below the surface of the sea. The pressure due to the water at this depth is P. On another day, the submarine is 26 meters below the surface of fresh water. The density of seawater is 1.3 times the density of fresh water. What is the pressure due to the fresh water at the depth of 26 meters? So we know the pressure in liquid is rho GH, and this, compared to this is for seawater. The depth will increase, so by the ratio of 26 by 20, and density will decrease because it's in fresh water, so that will be 1.3 times, which means 1 by 1.3. So if you do the math, that will be 1.3. This will cancel each other out, and the answer will be B. 12. A student cycles along a level road at a speed of 5 meters per second. The total mass of the student and the bicycle is 120 kilograms. The student applies the brakes and stops. The braking distance is 10 meters. What is the average braking force? So if we see, when we see the word force, right? We see F is equal to ma. Now we need to know the acceleration. We already have mass. So acceleration is velocity divided by time. But obviously we only have the distance and speed. How do we do that, right? So we can use this, one of the kinematic equations, v squared is equal to u squared plus 2as, and v squared would be, the final velocity will be 0 because it will stop, and this is u squared plus 2 acceleration, and s is going to be 10. So acceleration is going to be minus 1.25. 2.5 divided by 1.25, and this is going to be acceleration, and if you put that in this equation, force 1.25 into 120 is going to be 150 newtons. Now if you don't know this equation, there's another method of solving this. That would be to use the concept of energy. So we know that it is moving, so it has kinetic energy, and we know that work done is equal to change in mechanical energy, like kinetic energy or GPE. In this case, that will be KE. So 1 by 2 m v squared, that is the change in kinetic energy, that will be equal to work done, which is force. So yeah, force is what we're looking for, into distance. So 0.5 into 120 to 25 divided by 10, that is also 150 newtons. So be A. A bicycle braking system transfers energy from a kinetic energy store to an internal energy store. A motor converts energy from a chemical energy store to a kinetic energy store, which enables these energy transfers. So this kinetic energy to internal energy. This is called mechanical work, mechanical energy. And for this chemical energy to a kinetic energy store, this is converted by motor. And because this is a battery is working to provide this kinetic energy, so it will be electrical work. So the answer will be D. Object 1 is given a negative charge and placed on a balance. Object 2, which is also charged, is brought close to object 1 and the reading on the balance changes as shown. So it decreases, right? So which action would further decrease the reading on the balance? So firstly, this object 1 is negatively charged, and because the reading decreases, we can conclude that this is attracted to object 2, which means object 2 will be positively charged. So if we want to increase this strength, then we will have to either make object 2 more positive or object 1 more negative. So it says add the same number of electrons to both objects. If same number of electrons, it will have no effect. It will just be the same. And to remove the same number of electrons from both objects, again, if we perform the same action, it will not be different. See, transfer electrons from object 1 to object 2. If we do that, then this will become less negative, and this will become object 1 would become less negative, and we wouldn't want that. So for D, transfer electrons from object 2 to object 1. So this will decrease the electrons, which will make it more positive, and this will become more negative. So the answer will be D. A uniform wooden ruler is pivoted at its center. A load of 2 newtons is suspended from each end of the ruler. The pivot exerts an upward force F on the ruler. What is F equal to? So we can say that this is in equilibrium, and it also says uniform wooden ruler. So we know that its center of mass is at the center. And when it's uniform, right, we know that the force acting on it net force will be 0. So in this case, the force is in direction downwards and then upwards, right? So for downwards, we have these 2 loads and mass of the ruler, and for upward force, it's just F. So we know that this F will be equal to all of these 3 forces. So 2 plus 2, 4 newtons plus the weight of the ruler, D. A student carries out some simple exercises. Which exercise is the most work done? So work done is force into distance in the direction of force. So lifting through 1 meters. So this is 1 meters moved in 1 kilograms. This is work done against gravity. So we have mgh. So that will be roughly 10 joules. Pushing through 1 meters against frictional force is 4 newtons. So this is force and distance is this. So that will be 4 joules. And lifting through 2 meters, that will be 20 into 2, 40 joules. And pulling through 2 meters against frictional force of 2 newtons, so that will just be 4 joules. So the answer will be C. A balloon and a mass are attached to a rod that is pivoted at P. The balloon is filled with helium, a gas less dense than air, so that applies an upward force on the rod. The rod is horizontal and stationary. Which action causes the rod to rotate clockwise? So this will be clockwise, which means that this balloon will have a larger moment on this point. So move both the balloon and mass to 10 centimeters to left. But wait, so before we do this, right, we can say that this, okay, let's call this F1 and F2. So we can say that 20 F1 is equal to 30 F2. Right, so we can see this relationship. So we want the F2 to be larger, so we'll make it a subject. So that will be 2 by 3 F1. So when the moment caused by this F2 is greater than moment caused by F1, then we know that it will rotate clockwise. Move both the balloon and mass 10 centimeters to the left. So 10 centimeters to the left, that would be 40 F2 and then 30 F1. So these are the moments, right? So if we substitute this one into here, that will be 80 by 3 F1. So that's the moment caused by the balloon, and this is the moment caused by the mass. So if we compare that, right, 80 divided by 3 is 26.67, so that is smaller, so A will be wrong. And B, move both the balloon and mass 10 centimeters to the right. So to the right means 20 F2 and 10 F1. So 40 by 3 F2 is greater than 10 F1. So the answer will be B. A balloon is dropped onto a floor. Its speed just before hitting the floor is 3 meters per second, which change will result in a speed of 6 meters per second just before hitting the floor. Ignore any effects due to air resistance. So we want to change the final velocity. So again, we have two approaches here, kinematic equations or energy approach, but we use the energy approach here. So it wants, so in a way, in other words, it wants to increase the kinetic energy by 4 times, because 1/2 mv squared, right? So if velocity is changed by 2, then that will be 4 times. So it wants the kinetic energy to increase by 4 times. So we need to increase the gravitational potential energy, because it is going to be the source, since it is dropped from a height. So GPE has to be increased by 4 times. So drop the ball from double the height. Double won't be enough. It has to be 4 times the height above the floor. So B. Wait, so I just mentioned that you have to increase the GPE, right? So why not the masses won't work? the masses won't work because this mass will also increase, so there will not be like any change in terms of velocity. It will just go to the mass, because Ke will also has to be increased for this increase in mass. 3. A ball is dropped in an evacuated tube. A series of photographs is taken at equal time intervals from the time of release. Another ball of the same size but twice the mass is also dropped in the same evacuated tube and photographed. Which diagram shows the motion of the heavier ball? So it says it's a same evacuated tube in a vacuum, so the mass air resistance it won't have any effect. So they all experience, both of the balls will experience the same acceleration, the gravity from the earth, so it would just be the same. B. A piece of wire is 40 centimeters long and has a diameter of 2 millimeters. Its resistance is 0.3 ohm. Which wire of the same material has a resistance of 0.15 ohm? So it wants to decrease the resistance by half. So you can decrease, okay, so resistance is equal to rho L by A. This rho is called resistivity, which depends on the material. So now it's the same material, so you don't really need to consider that. And so this will be decreased by half. Okay. So firstly, length 20 and diameter 1. So length 20 will give a smaller, by half, and diameter will also change, so the effect won't just be 0.5 anymore. So A is out. And B, again, if we decrease the length by half, then this effect is already achieved. But if we change the diameter more, then it won't be the same. It won't be half anymore. So for C and D, wants to increase the length by 2 times. So to achieve this effect, we have to increase the area by 4 times, right? Because they are inversely proportional. So if we want to increase the area by 4 times, the diameter will have to increase, and diameter will increase by 2 times because area is equal to pi over 4 d squared. So the effect will have this squared factor, so it will be d. The circuit diagram shows a DC power supply connected to 2 resistors, R1 and R2, and 4 diodes. Which statement is correct? Okay, so it's all about current, so we'll trace the current. Okay, so R1 here, in this junction it won't go to this side because the diode is in wrong direction, so we'll follow this, and again it won't go there, just here, and then right here, and it can follow this, or even this, can follow both direction. So there is a current in R1 and also in R2, so we can say that it is A. We just need to trace the current, and current will not enter if the diode is in wrong direction. A crane on a building site lifts bricks of total mass 200 kilograms initially at rest on the ground with uniform acceleration. 1. The bricks are at 5 meters from the ground. They have a speed of 5 meters per second. How much work is done during the process? So work done, as I mentioned, is change in mechanical energy, right? And in this case, the bricks will gain both GPE and KE. So we need to calculate for both. So GPE and GH. So we will just take G as 10 for MCQ. It's fine, unless the given choices are like very close to each other. You can use 10. H is 5 and KE is 1/2 E squared. We need to add both. So 200 into 10 into 5 plus 0.5, 200 into 25, that will be 12.5 kilojoules. C. An object falls in a gravitational field with air resistance. Which distance time graph shows this motion? So we know that in that case, right, the speed time graph looks something like this. We just know that, right? And so C will be automatically out because this is speed, not distance. So we can go through each graph to see whether we can get the speed time graph or not. So we know that this the gradient of distance time graph will give you the speed, right? So for A, the gradient here is increasing, and then it will come to a constant value later on, which matches the speed time graph, because now the gradient is also increasing, which means speed is increasing, and then it will come to a constant. So A will be the correct answer. A beam of weight 6 newtons is suspended from two strings P and Q. String P is 30 centimeters from the left-hand end of the beam as shown. String Q is not shown. The tension in string P is 2 newtons. What is the tension in string Q, and where is it attached so that the beam is in equilibrium? So we just need this to be in equilibrium, which means sum of the moments will be 0, and the clockwise moment has to be equal. So where do we put the pivot? We can put the pivot right here, it's fine. And this will be anti-clockwise moment 60 Newton centimeter, and this will be clockwise moment 120 Newton centimeter. So we need anti-clockwise moment. Anti-clockwise moment of 60 Newton centimeter. So we just multiply those values, right? See if it gives us 60. This is 40, no, this is 60, this could be right. This is also 60. Like 8 into 7.5 is also 60. So since this is an equilibrium, we can consider two situations, right? Moment and also force. Which means that the net force will also have to be 0. And we need an upward force of 4 newtons in this case. 2 plus something has to be equal to 6. So we will choose the one with the 4 newtons, B. Cables transmit electrical power from the output of the transformer at a power station to the input of the transformer at a substation. The power at the output of the transformer at the power station is 400 megawatts. Which situation delivers the most power to the input of the transformer at the substation? So we want the most power, the least power loss. So power loss is given by P is equal to I squared R. And this resistance will be decreased, has to be smaller, and current also has to be smaller. So potential difference. So we say that P is equal to IV, and we want the current to be smaller, so voltage will has to increase. We will take the larger voltage values, which is C or D. And for diameter, we'll be concerned with the resistance. Resistance is equal to rho L by A. And so if you want the resistance to be smaller, area has to be greater, so diameter will be greater, which is C. The diagram shows a wooden beam PQ of negligible weight, which is attached to a wall by hinge at P and kept in horizontal position by vertical rope attached at Q. The beam is 3 meters in length. A man of weight 800 newtons walks along the beam from P to Q. What is the distance of the man from P when the tension in the rope at Q becomes equal to 500 newtons? So this distance is 3 and this is 500, which means that the anticlockwise moment will be 1500 Newton meter. And so we want this to be in equilibrium, which means the clockwise moment provided by this man will be equal to this 1500 Newton meters. So we just need to divide. Okay, so 1500 is equal to 800 into some distance. So D will be equal to 15 divided by 8, which is 1.875. And this is asking the distance from P, so we don't need to do anything anymore. So that will be 1.9 meters in 2 significant figures. The specific heat capacities of aluminium, iron, ethanol, and water are given. 1 kilogram of each metal is put into 5 kilograms of each liquid. The starting temperature of each metal is 60 degrees Celsius. The starting temperature of each liquid is 10 degrees Celsius. Which example has the highest final temperature? So we know that C is equal to E by M delta T. We start with metals. So they have the same initial temperature, which means that aluminum will have more energy because E is equal to MC delta T. When temperature is constant, then they are directly proportional to each other. So we will want aluminum with the one with the higher thermal energy for the highest final temperature. So it's either A or C. And for liquid, because we want to measure the temperature, right? It needs to be more willing to change its temperature, meaning that if they receive the same amount of energy, then we have to use the one with higher flexibility, the higher increase in temperature, which means lower specific heat capacity. So that will be ethanol. We choose A.